All right, so now we're getting ready to be a little excited, and I know I'm thrilled as much as you are, I'm sure. This section is about graphing, okay? You thought you had a hard enough time with graphing straight lines. Now you're gonna find out how it is to graph circles, okay? I promise in a way it's actually a little bit easier to do with circles, okay? So bell work wise, given circle M has an area of 3,140 centimeters squared and a sector AMC with area of 314 centimeters squared, find the indicated measures, okay? So again, we're gonna go back and we're gonna pay attention to all those different equations that we've talked about throughout this entire unit. We're gonna look at the area of a circle, we're gonna look at the circumference of a circle, we're gonna look at the arc length of a circle, and we're gonna look at the area of a sector, okay? And we have to keep all of those kind of in our minds. If I'm looking at those, I need to figure out which one is gonna be able to give me what I need here, okay? So let's write those off to the side here. So circumference was 2 pi r, or pi times the diameter. Area was pi r squared. Arc length was the measure of AB over 360 times 2 pi r, or the circumference. The area of a sector was the measure of AB over 360 times now pi r squared, okay? And the idea here again is then to piece out which one do I have or which one can I use. So if I'm paying attention to number one, it's asking me for the radius of M. And again, looking at what I've been given, I know the area of a whole circle and I know the area of the sector, okay? But I'm looking for the radius. So all four of them have radius involved. However, I don't actually know the measure of AB yet, okay? That's in fact here. So I can't use that yet. I would not use these bottom two. So then I can question, do I need to use this one for area or this one for circumference? Well, in the given statements, I don't give you the circumference, so you can't use circumference. You have to use area. So if I find the equation with area and I plug into it, area equals pi r squared. The whole area was 3,140. And again, I'm gonna do that thing that I did last section. I'm gonna flip this. I have pi r squared. And if I divide by pi, that cancels my pi's. And I have r squared equals that 3,140 over pi. And again, what happens here is I need to take the square root. And again, I'm going to do the top and bottom over here. Square root and the square will cancel. And that's now going to give me that the radius let's work this out again. Hold on. Okay, if I look at this again, I have that square root in the bottom. I need to get rid of that. So I'm going to multiply the top and the bottom by the square root of pi. Which equals then square root 3,140 pi over pi. So r equals this. Okay, again, as mentioned, I'm not saying these are friendly looking numbers because they're not going to necessarily be, but they are what they are. Okay, number two, find the circumference of M. Okay, so here I'm asking specifically for the circumference. So if I'm looking for the circumference, I know the circumference equations are 2 times the pi times the radius, or or pi times the diameter. Well, number one just had me find the radius. So now I know the radius. So I can plug into that equation. I have C equals 2 pi r, which means I have 2 pi times this radius. The square root of 3140 pi over pi. But if we pay attention here, notice that the pi and the pi in the denominator will cancel each other out. So with this one and this one will cancel, which leaves me just the circumference to be 2 times the square root of 3,140 pi. Okay, number 3. Should put that up there. Number 3, we're looking for the measure of AC. So now again, I know the circumference, I know the radius, and I know the area of a sector, and I know the area of the entire circle. So I need to use one of these equations that has measure of AC. But I need to have everything else piecewise that's missing. So if I look at this equation here, do I know the length of AC or the length of AB? Well, no, it's asking for it in number 4. So we can't use that equation, which means I'm going to by default use this second equation. Okay? And again, what happens here is this again is the area as a whole. So I'm just going to, instead of putting this, I'm going to use a circle instead of pi r squared. Okay? So the area of a sector is the measure of AB, or here, let's do measure of AC like it's asking, over 360 times the area of the circle. Okay. And again, we're going to plug in everything we know. So we know the area of a sector is 314. I know that I need to find the AC, measure of AC. Over 360 times that 3,140. Okay, because that was the area of the circle given. Here then, again, I'm just going to rearrange things. So that leaves me 314. I'll put it over 1 equals, I have 3,140 over 360. Times the measure of AC. And again, I'm going to multiply then both sides by the reciprocal. Okay, notice here I don't have a lot of room, so I'm going to try to smash it in here. We'll see what happens here. But I'm going to go ahead and reduce this as I can real quick. Okay, so the measure of AC is going to be equal to what? So I have 314 up top and 3,140 in the denominator. If you pay attention to that, I can divide by 314, which leaves me 360 over 10. Which then reduces to be 36 degrees. And again, your other option was to take 360 times that 314 and then divide by 3,140, which again still would give you 36 degrees, okay, if done correctly. Number 4, again, now I'm looking for the length of AC. So I'm going to plug into this equation now for the length. And I know now AB, measure of AB, is 36. So I'm looking for this portion. But I know this, and I know the circumference. So now I'm going to plug into AB, length, is the measure of AC over, let's do AC here, not AB. Measure of AC over 360 times, and again, I'm just going to put circumference because we already know the circumference as a whole. It's right above it. Okay, so we're going to find AC. Measure of AC was 36 over 360 times, and again I'm going to do this as a fraction. Okay, reducing wise, 36 over 360 should simplify pretty quick and easy, right? So this becomes AC is equal to 1 over 10 times 2 square root of 3140 pi over 1. And again, looking at that 2 and the 10 in the denominator, I can reduce those, which gives me 1 over 5, which means I have the square root of 3,140 pi all over 5. Okay. Graphing circles. All right, again, this is going to sound really super fun, and you might be terrified right now watching this video. However, I do promise that this is not as bad as it might seem. Okay, what you need to know the center of the circle, and you need to know the radius of that circle. Okay, standard form of a circle is given by the equation, the quantity x minus h squared plus the quantity y minus k squared equals the radius squared. Okay, so the HK thing should really look familiar because we did that when we talked about transformations. That came into play a lot. And again, I told you it was going to come into play quite some time when you're talking about different equations. Okay, so h comma k, again, it's the opposite of whatever's inside those parentheses, is then the center of the circle as an ordered pair. I'm going to expect you to write the center as an ordered pair. So you should write C equals parentheses, whatever the opposite is with the x value there in parentheses, comma, whatever the opposite of the number is with the y in parentheses, and then close the parentheses. Okay. To find the radius, you need to find just r. So I'm going to take the square root of that number. And then again, on your paper, I want to see r equals, and then give me the number. Okay. How to plot it. Again, this should be really easy, actually. Step one, once you identify that center, you're going to plot that point. Okay. The only thing that I can suggest here is to pay attention to what you're doing. Make sure that you're going left or right first, and then up or down. Okay. Remember, it's x comma y, not y comma x. Step two, then you're going to identify the radius of the circle. Okay. And when you identify the radius of the circle, then you're going to go back to that center, and from that center, you're going to go up that many units and make a dot. Go back to the center, go down that many units and make a dot. Go back to the center, go left that many units and make a dot. Then go back to the center one last time, go to the right that many units and make another dot. Okay. Step three is where it gets really interesting because, man, some of your circles are going to look fantastic. I've seen diamonds, which are not very circular, but people try. Okay, so try as best you can. I'm not looking for perfection here. No, you don't have to go run out and get a compass and make sure that it's perfect. Some of you artistic people will make sure that they are circular or a little more circular in nature than some of you, because otherwise it will really, really bother you. But draw the best circle that you can. Okay. So lots of examples here. Pages 4, 5, 6, and 7 are 2 examples on each page. So you have 8 total examples here, and then it's all you. Okay, so here you'll notice that number 1 and number 2, the equations are a little bit different than what I gave, right? But I can modify this. I can change this so that it becomes x minus 0 squared plus y minus 0 squared equals 100. Okay. Notice that if I add or subtract 0 to something, it doesn't change it at all. So what happens on the x minus 0 quantity squared? It's just x squared. Okay, but it just gives it a form that makes you understand what's going on. Okay. The center then, so c equals the opposite of what's in here and the opposite of what's in there. Well, there's zeros. So it's just 0, 0. It's the origin. Okay, which is right there. The radius then is the square root of whatever's here. So square root of 100, which is 10. And from this center, you're going to go up 10, make a dot. You go back to it, go down 10, make a dot. Go back to it, go left 10, make a dot. Go back to it, go right 10, make a dot. Okay, make sure that you're counting, because the thing that I notice here a lot is people don't actually count, okay, and they always put a dot in the wrong location. So make sure you're paying attention to that. And then again, as best you can, draw the circle as nicely as you can. So we go up and around. Okay, looked fantastic until this last bend, and then smashed a little bit. I don't know what's going on. Okay, but again, do as best you can. All right. Looking at number 2. Number 2 again is a similar situation. I'm not going to rewrite this one. I'm just going to go with it. Understand that the center here, again, there's nothing inside parentheses with them. So C is going to equal the ordered pair of 0, 0. Again, making sure it's an ordered pair. R is then the square root of 64, which is 8. Okay, which is great. So we have 0, 0, dot. I go up 8 units, dot. Back to the center, down 8 units, dot. Back up to the center, left 8 units, dot. Back to the center, right 8 units, dot. Okay, and then again, draw it as best you can. So we go from here, go up and around. Okay, that one looks a lot better. All right, questions? These are going to be worth 3 points apiece. I'm going to give 1 point for the correct center identified. I'm going to give 1 point for the correct radius identified, and 1 point for the correct graph. Okay, so make sure you pay attention to these. Three and 4. Give myself a little more room in the graph here. Actually, I'm not sure if that's going to help me or hurt me, because it's harder to graph on a larger scale. Okay, again, looking at the center again is the opposite of what's inside of here and here. So now I actually have numbers inside of here. So the center here is the opposite of 7, which is negative 7, comma, the opposite of 6, which is negative 6. The radius is the square root of that number, so square root of 9, which is 3. Okay, so again, plot what you know. So negative 7, negative 6. Negative 7 goes left 7, and then down 6. We have a dot here. And my radius is 3. So from this dot, I'm going to go up 1, 2, 3. Count the lattice lines, okay, the intersections. Go back to the center, go 1, 2, 3, dot. Back to the center, go 1, 2, 3, dot. Back to the center, 1, 2, 3, dot. Okay, now I have my points. I need to go all the way around. Okay. Number 4 there, the center is, again, opposite. So that'd be negative 2. Opposite of negative 4 is positive 4 now. The radius, again, is the square root of the number that's on the right-hand side. which is 6. Okay, so again here we go right or left first. So I go left 2, and then up 4, because it's positive 4. So I have a dot here. From that position I go up 6, down 6, left 6, right 6. So from here I go up 1, 2, 3, 4, 5, 6. Back. 1, 2, 3, 4, 5, 6, dot. Back. 1, 2, 3, 4, 5, 6, dot. And back. And then go over 6 here. 6. And then draw the circle again as best you can. Okay, it doesn't get more complicated than this, folks. All you have to do again is take your time. Remember, take the opposite of the numbers that are inside the parentheses and take the square root of the number that's on the right hand side. Okay. Again, just showing different scenarios here though. So these ones, notice that one of the variables doesn't have a number in parentheses with it. Okay, so if that's the case, we go back to that first scenario where I had zeros, right? So the center here, there's nothing inside here, so that's a 0, comma, opposite of here is -3. The radius is the square root of that number, so square root of 49, which is 7. Again, graph what you know. So 0 and -3. So we start at 0. We don't go left to right. We go down 3, make a dot. 7 is my radius. So I'm going to go up 7. So I have 3, 7. From here I go to -7. Go back to positive 7. I can go down 7, which puts me at -10. And then again, graph my circle as best I can. Okay. Number 6, again, similar situation, but now I have the y without a variable or a number with it. So C, or the center, is the opposite of that, so 9, comma, 0. Radius here is the square root of 1, which is 1. So now I'm going to the right 9 units, making a dot. And notice that my radius is 1, so I'm going to go from here, I'm going to go up 1, left 1, down 1, right 1. Okay, and we again make it best a circle as we can. Okay, and I can see it now. Every semester I have somebody in the class that's like, oh, that's such a cute circle. Okay, it's adorable. All right, but moving on. Number 7. Possibly. There we go. Number 7. Okay, notice that this is as complicated as it's going to get. So on the radius, you'll notice that 20 is not actually a perfect square. Okay, so that leads into a complication. So number 7, the center stays the same. Opposite and opposite, so -5, comma, +3. But the radius here again is square root of 20. Okay, I want to see a couple things here. I do want to see you reduce this. I do not want to just see the decimal value. However, you are going to still find the decimal value so that we can figure out how to graph these things. Okay, so remember to simplify this, we find the largest perfect square factor, which means square root of 4 times 5. Square root of 4 is a perfect square, so that's 2. Times the square root of 5. Okay, so this is the radius that I'm looking for. That's the entire radius, the actual radius. Okay, the exact value. However, again, for graphing purposes, I need to know that the radius is approximately 4.47. Okay, so how does that help me? That tells me that I'm not going to go under 4, but I'm also not going to go over 5. Okay, so I'm going to go about 4.5 units up, down, left, and right from the center, and then graph again as best I can. I am not going to take out some kind of little micromanaging tool to make sure that you're exactly 4.47 units. Okay, so do what you can. -5, +3. Okay, and again I'm going to go 4.47 units. So again about 4.5. I have 1, 2, 3, 4, and about half. 1, 2, 3, 4, and about half. If it graphs. 1, 2, 3, 4, and about a half. And again, 1, 2, 3, 4, and about a half. Okay, and graph again as best you can. Ooh, that's a good circle. Okay, number 8, same thing again. We're going to take the opposite, so the center. Opposite of -4 is +4. 0. There's nothing there. The radius is the square root of 10. Okay, you'll notice that the square root of 10 does not actually reduce. The only factors of 10 are 1 and 10, 2 and 5, none of which are perfect squares that are going to help us out. So that would be equivalent to approximately 3.16. Okay, so again, how does that help us? That means that we're going to go just a little past 3. I'm not going to put it at 3. I'm going to put it a little past 3. Okay, so I'm going to go to 4, 0. I'm going to go right 4, make a dot. I'm going to go up 3, 1, 2, 3, and just a little bit past. If it makes my dot. There we go. Left 1, 2, 3, and a little dot. Okay, down 1, 2, 3, dot. To the right, 1, 2, 3, and then a dot. Okay, again, notice again, we're just slightly past the 3 unit mark. And then again, graph as best you can. Ooh, and another great circle. Okay, again, this is not that difficult. It's just time consuming. Okay, take your time, ask questions if you have them, and just let me know what's going on. Okay, there's one more unit in this section that is graphing in general form. That's a little bit more complicated and a little more time consuming. So there are less problems on the homework. Okay, but again, for now, if there's any questions, comments, or concerns, by all means, let me know.